Hello everyone. Welcome back to Demonstrator. Today, we're diving into a classic experiment in physics, the Millikan Oil Drop Experiment. Ever wonder how we figured out the electric charge of a single electron? And even though we've never actually seen an electron, Millikan helped us measure its charge over a century ago. Let's find out how he did it. So, what was Millikan's goal? In 1909, Robert Millikan, an American physicist, set out to measure the charge of a single electron. It might seem simple now, but back then, no one knew this charge, even though we knew electrons existed. Millikan designed his experiment using oil droplets because they were small, easy to control, and wouldn't evaporate quickly. He sprayed tiny oil droplets into a chamber with two metal plates, one on top and one on the bottom, connected to a power source to create an electric field. But before calculating the charge, he needed to find the mass of each oil droplet. To do this, he observed how the droplets fell under gravity alone, without any electric field. Millikan measured the speed of each droplet as it fell. When a droplet falls at a steady speed, we call it terminal velocity, when the force of gravity and air resistance balance each other out. By knowing the terminal velocity, Millikan could calculate the droplet's mass using a basic formula, where this is the viscosity of air, and this is the gravitational acceleration. With this calculation, he could estimate the mass of each droplet with impressive accuracy, considering the time period. Now, with the mass known, Millikan introduced X-rays into the chamber. The X-rays ionize the air around the droplets, adding or removing electrons and giving the droplets a slight charge. This process gave some droplets a negative charge, which was exactly what Millikan needed. Once Millikan had charged oil droplets, he adjusted the electric field between the plates. This created an electric force that acted against gravity. By fine-tuning the electric voltage, Millikan could find just the right balance where the upward electric force exactly matched the downward gravitational force, keeping the droplet suspended in midair. This balancing act was key. When the forces were balanced, Millikan could measure the electric force needed to hold the droplet steady. At this point, Millikan had everything he needed to calculate the charge on each droplet. He used the formula, where Q is the charge on the droplet, F is the electric force, and E is the strength of the electric field. By using his previous calculation for the droplet's mass, he could determine the electric force required to balance the droplet. After repeating the experiment on many droplets, he found something remarkable: each droplet's charge was always a multiple of the same small value. This smallest unit of charge, Millikan realized, was the charge of a single electron. So, what did Millikan discover? He measured the charge of a single electron to be approximately this. This discovery was groundbreaking. It provided a deeper understanding of atomic structure and opened up new pathways for future research in physics, chemistry, and electronics. To wrap it all up, the Millikan Oil Drop Experiment used basic principles of gravity, electricity, and careful calculations to measure the tiny charge of a single electron. This simple but powerful experiment helped reveal the hidden world of atoms and electrons. Thanks for tuning in to Demonstrator. If you found this explanation helpful, don't forget to like, share, and subscribe for more science content. See you in the next video.